4. Okay, our quick look at the calendar says today we talk more about factoring. Last class we did some factoring of easy trinomials, things that look like x squared minus x minus 12. We wrote those things as products of two binomials, two things in parentheses multiplied together. Today we're going to do a little bit different kind of factoring and then the harder versions of those trinomials that we saw last time. And coming up, very important date for us is this coming Wednesday. Quest number 3 out of 5 is coming up on Wednesday. Again, the material that we covered today is not on the quest, and neither is the material we covered on Friday. So the material is only on classes 19 to 23. And I will point out again that inside the packet are sample quest problems. If you hunt around just a little bit, you'll find them. So I'd recommend that you go through all of those sample quest problems. If you have any trouble on them, there's videos on YouTube and there's solutions up on Moodle. Questions on the calendar? Okay, so that's that. One more thing about the calendar. Tomorrow is a special day for a couple of reasons. Number one, tomorrow is election day, so you're going to get out and vote. If you don't know how to vote or where to vote, or if you're registered to vote, see me after class and I will show you the website for Massachusetts voting stuff, which also means you're going to get informed on the 4 polling questions. There are 4 yes/no ballot questions that are going to appear on the ballot tomorrow. So in order to be informed, you should just go read. Again, I can give you the same site, which tells you what the 4 questions are and short arguments in favor and against each of these potential motions. When I looked at this website, to decide how I wanted to vote, I didn't know anything about the 4 questions. It took me 5 minutes to read and decide what I wanted to do for the 4 questions. So it's really not a large commitment of time to decide how you feel about the 4 questions, but you got to make that little bit of a commitment before you vote tomorrow. The other reason that tomorrow is important is tomorrow is advising day here at GCC. So there are no day classes and there are also no evening classes tomorrow here at GCC because we want folks to come in and meet with their advisor and get registered for the spring semester. Tomorrow is the first day that you can register for the spring semester. So if you're able to come onto campus tomorrow, that would be great. You can make an appointment to see your advisor. They probably have their schedule outside their office door. Any questions about that? Okay. So again, we're here on page 34, and we'll jump in right at the top. Can we go to Tara for the daily summary? Thank you. Okay, so first a quick apology. It's a long demo. We'll give you some time to do group work, but we've got a lot of material we're going to kind of cruise through together first. We begin by looking at some special factors and seeing why we call them special. So let's look at this first thing, 7 minus y times 7 plus y. We're going to go ahead and do our distributive thing or lobster claw thing here, and something funny is going to happen. So when we multiply the 7s together, we get 49. And then I'll do the outer terms here. 7 times y is just positive 7y. How about the inner terms? Negative 7y. And finally, the last terms, minus y squared. And what funny thing happens in the middle? Those 2 terms in the middle cancel. So we just get 49 minus y squared. And that is atypical, because for all the other things we've been multiplying together, we'd always have 3 terms in our answer. But in this case, the 2 middle terms, which normally combine and still appear there, cancel each other perfectly. We'll see the same kind of thing happen in this next example. So again, we'll lobster claw this together. So 2x times 2x is 4x squared. Outers, 2x times negative 5y. Negative 10xy is good. Inners is a positive 10xy. That's the canceling that we'll see. And then the last, minus 25y squared. And again, these 2 things in the middle, the outer and inners, cancel perfectly. So we just get 4x squared minus 25y squared. And the idea here is that we should recognize the pattern that makes these things in the middle cancel. 7 minus y, 7 plus y. Exactly the same, except 1 minus, 1 plus. Yes? And in the next example, 2x plus 5y, 2x minus 5y. Exactly the same, 1 plus, 1 minus. And that's what makes it so that the 2 terms in the middle cancel. And so we'll go on to number 2, Lydia. Okay, so we're going the other direction now. Let's start on the right-hand side. A plus B times A minus B. That's exactly the pattern that we saw, right? 1 plus and 1 minus, otherwise they're exactly the same. And it turns out that's equal to A squared minus B squared, which is just what we saw up here. 7 squared minus Y squared, 49 minus Y squared. And so if we go the other direction, if you're given something that looks like A squared minus B squared, you can factor it. That's the harder direction, because you recognize, oh, it's that special thing where the two middle terms canceled. And the way they canceled is an A minus B and an A plus B. So we'll try 3, where we go the harder direction. We're going to factor these using this difference of squares formula. So x squared minus 64, start with 2 blank parentheses. And we need the 2 first terms to multiply together to give me x squared. X and x, that's no surprise. And then we need the 2 last terms to multiply to 64. And they have to be the same number. So you can't say 16 times 4, even though 16 times 4 is 64. It's got to be the same number, and 1 plus and 1 minus. And that's it. And so this is really, it's kind of a different sort of factoring than we saw last class, right? We're not doing the product sum idea. We're just recognizing a pattern, and this new pattern has a nice little formula. So 100 minus A squared, yeah, Casey. So x minus 8, x plus 8 is also correct. Good question. Okay, next example, 100 minus A squared B squared. Here's what we need to recognize. It's 2 terms with a minus sign in between, and each of these 2 things is a perfect square, right? 100 is what times what? 10 times 10. A squared B squared is what times what? AB times AB. That's what makes this formula work, and as soon as you recognize that, pretty much the answer is there. So again, the 100 you said was 10 times 10. A squared B squared is AB times AB, 1 plus and 1 minus in either order. Next example, x to the 4th minus 16. It is the same pattern, 2 terms, minus sign in the middle. Both of them are perfect squares. So we start with the parentheses. 2 things that are the same that are going to multiply to give me x to the 4th is x squared and x squared, right? And then 2 of the same numbers to give me 16, 4 and 4. You can't do 8 and 2. It's got to be the same number in order for this canceling to happen in the middle. And again, 1 plus and 1 minus in either order. Okay, so here's the deal. This problem isn't done, and for the first time, we're going to have to factor multiple times in one problem. So x squared plus 4 is not this pattern, because what's the key thing between the 2 terms in this pattern? It's got to be a multiplication. In between the 2 terms, what does it have to be? What's in between the 2 terms? Here and here and here. Subtraction. It's got to be a subtraction. It's nothing other than subtraction. So if you give me 2 terms that are separated by a plus sign, I cannot use this formula. But if you give me 2 terms separated by a minus sign, I can. And so I'm going to copy the x squared plus 4. Can't do anything with that. But the x squared minus 4 is 2 terms separated by a minus sign where both terms are perfect squares. And so I'm going to underline this guy in red and then break it down further in red. What 2 terms will give me x squared? X and x. What 2 terms will give me the 4? 2 and 2. And again, 1 plus and 1 minus. And now this one is done. 8. Okay, so first our obligation is to factor as far as we can. So just one factoring isn't necessarily enough. We got to factor everything as far as possible. The second term, x squared minus 4, is a pattern we've just seen a bunch of examples of. But the first guy, x squared plus 4, is not this pattern. This is the pattern we're looking for. It's two perfect squares separated by a subtraction symbol. But if you give me two perfect squares separated by an addition symbol, I say, well, that's too bad. I can't do anything with that. Well, see, the thing that made this guy work up here, so I think we bought the fact that 7 minus y times 7 plus y was this, right? And the only reason that we lost the terms in the middle is because they canceled, right? And the only way that they canceled is if one of them is a positive and one of them is a minus, yes? And so the only way we're going to get one plus and one minus is to have that in the original problem. So these have to be a plus and a minus in the original. And then the last piece of this puzzle is if you multiply negative y times positive y, what do you get? You get negative y squared. And that's the minus sign that comes out. The only way those things in the middle cancel is if you have one of each sign. And when you multiply one positive and one negative, it's got to be a negative every single time. So it's important to notice that that is a subtraction in the a squared minus b squared formula. So kind of piggybacking off of Nate's question, what do we think about x squared plus 9? It cannot be factored. Yeah, I mean, so you might try, so don't copy this because it's wrong, but you might try this, x plus 3, x minus 3. But what is that going to give you when you multiply the 3's? It's going to give you a minus 9, yes, which is not that. So then we say, oh, okay, we can fix this. We got to get a plus 9, so let's get a plus 9. But when we do outers, what do we get? Yeah, x squared is the first, and then we do the outer terms is plus 3x, and then the inner terms is another plus 3x. And that gives you a plus 6x, and they didn't cancel. And we need them to cancel because I don't see a plus 6x in the original problem. So we can't do anything with this, even though it looks quite similar to the other problems. Cannot be factored, or prime was the other thing we called it. Okay, last example, 3x squared minus 12. I see two terms, I see a subtraction, but is 3x squared a perfect square? No. Is 12 a perfect square? No. Okay, so it's not this pattern. We can't do this pattern. What we can do is actually something different, something that we haven't seen formally together. And what we're going to recognize is that there's a number that goes into 3x squared and 12. What goes into both? It's 3. So we're going to factor that 3 out to the front. Now this could be something that's quite easy for many of you and challenging for others of you. We're going to pull the 3 out in the front. What's that? Yeah, got to have a common factor in order for us to do this. And basically all we're doing is undoing the distributive property. I'm going to go ahead and subtract that. I'm going to put that subtraction sign in the middle here. So we just got to fill in those two blanks in the parentheses. Yeah. So we need 3 times the first guy to be the 3x squared. Okay, so the x squared is what we need there. And then 3 times something to give me the 12 is 4. Do we see that? So it's just undoing the distributive property. This is a really important kind of factoring. It's called factoring out the GCF, or the greatest common factor, because 3 was the biggest thing that went into both 3x squared and 12. And so this is always the very first thing to look out for, and we didn't look for it in any of the other ones, but I'm telling you now, this is the first thing on any kind of factoring problem that you should look for. Is there something that goes into all the terms? Because if there is, you take it out right away and you make your life a lot easier. What's that? So if there isn't a number that goes into everything, then we have to go back and rely on the other factoring techniques that we've seen, including all the ones in this chart and including all the ones we did last class. So you can only say it's prime once you've exhausted all the factoring techniques. All I'm saying is that this idea of looking for something that goes in all of them is the first one to try. Mm-hmm. So this guy, I don't know if you meant to make it, but this guy actually follows this same pattern that we saw in this table. But if we made it like an 11, that one is prime. Yeah. Okay, so this guy actually isn't quite done. So we're going to copy the 3, But x squared minus 4 is hopefully starting to look familiar. It is this same pattern here. X and x, what two numbers give me the 4? 2 and 2. 1 plus, 1 minus. That's factored completely. Okay, let's move on to the next page. And we'll go to Kira for number 4, please. Okay, number 5. We've got this product 3x plus 2 times 2x minus 5. And so let's go ahead and just do our product sum thing. So what's the product? So remember, we would just look at these last two numbers here. What's the product of those two numbers? Is negative 10. And what's the sum of those two numbers? Negative 3, right? Add those guys up. So the product and sum are negative 10 and negative 3. And so maybe, you don't need to write this down, but maybe when I multiply these together, I'll get something like x squared, and then we remember the sum was always in the middle and the product was always at the end, remember? Like if I just gave you x squared minus 3x minus 10, you'd say, oh, great, I need the product to be this thing, and I need the sum to be this thing, yeah? That's what we did a bunch last class. Let's actually expand this thing and see what happens. So again, we're going to lobster claw here. So we multiply the first, what do we get? We get 6x squared. And then we'll do the outers, minus 15x. And the inners, plus 4x. And the last is minus 10. Six x squared minus 11x minus 10. That's right. Yeah, so I'm going to compare these two guys. Okay, so probably it was silly for me to put an x squared here because I could have seen that it was going to be 6x squared, right? That wasn't hard to see. So I guess I should have had a 6x squared there. But more troubling than that was that my sum of negative 3 all of a sudden magically became a negative 11 in the answer here, right? Unfortunately, there isn't anything we can factor out of 6, 11, and 10, but that is definitely the first thing to look for. So this is really bad news, gang, because if you played the game and you said, oh, I need two numbers whose product is negative 10 and sum is negative 11, which is what you would have done last class, you wouldn't have found the numbers because the actual numbers had a sum of negative 3. That's what makes these guys much harder, is that we can't use our product sum idea. Okay, so we know that factoring 6x squared minus 11x minus 10 has got to give you a 6x squared, right? We've got to multiply the first two terms and get 6x squared. So let's put that in this blank. First two terms definitely have to be 6x squared. And the last terms had to multiply to get what? What did we get when we multiplied the, we got a minus 10, right? I mean, that minus 10 we got right. So last terms multiplied to give me negative 10. But the whole add the two numbers and get negative 11 just it doesn't work. And so what you could do is a very lengthy trial and error where you look at all the ways there are to multiply two things in the front to get 6x squared and two things in the back to get minus 10, and you crush your fingers and hope that you get the middle minus 11x. Unfortunately, it's a lot of trial and error, so I've typed it out here so we don't have to spend time looking at everything. But there are 16 different possibilities. What two things could multiply and give me 6x squared? It could be 3x and 2x, which is what the answer was, or it could be 6x and 1x, which wasn't the answer, but you wouldn't know that going into this problem. And then what are the numbers that I can multiply to get negative 10? We could do 5 and negative 2. We could do negative 5 and positive 2, which is a different thing and would give us different answers. Or we could do 1 negative 10, or wait, we said 1, -10, -1, +10, which again is different. And it turns out there are 16 different possibilities in those things that we listed. And one of these is the answer. Do you see it? Which one is the one? Is it this guy? Was that, I mean, like we only know the answer because we happened to multiply this problem out at the start. Was it that one? Yeah, okay, but this would be a long process if you just said, okay, wasn't that one? What's this one? Oh, wasn't that mean of me to put that last? I mean, like you might have to go through 16 possibilities before you find the one that works. What does that mean? It means actually lobster clawing each of these guys together until you get the answer that you want. And in this case, it might take you 16 different lobster claws to get there. The point of this example is that there's got to be some better way out there. This would be very time consuming to multiply or FOIL all these things together until you find the one that had the -11x in the middle. Okay, so if you want to do trial and error, no problem. But if you want another method, and I think this is a better method, then we're going to see it here. So one last observation we need before we can actually do this new method, which starts on the next page. Yeah, so -3x has nothing to do with this problem, and you can't use it at all. And the -11x just kind of comes out of no place, and it's really hard to see where it comes from. So so this method that we're about to use is my best suggestion for how to tackle these hard factor problems. So we're going to multiply this using the box method. I don't know how many of you remember doing this, but let's give it a shot. So I got a 3x there, +1 there. So just copy them on the top and left. And so we remember how to do this, right? We multiply the two guys together and we put it in the right box. So that's a 15x squared there. So go ahead and fill in the other three boxes. So multiply, pay attention to the signs. Okay, so check your answers against mine. And then correct my answers. Thank you, Nate. Okay, so here's the last observation that we need. For some strange reason, I want you to multiply these two things together, and I want you to multiply these two things together. So can we multiply just the two diagonals? So multiply the two things in red, and then the two things in green. What do we get here when we multiply? That's -30x squared, okay. All well and good. And now multiply on the green is -30x squared. And it's surprising, but it turns out to be true that anytime you do this box method, if you multiply the two diagonals, always going to be equal. Always equal. Yeah. So if you want to see why, you can ask me later after class. I'll tell you. But anyway, it's just a fact that we're going to need on the next page. So this entire page is a description of the method that we're going to use to factor these really hard trinomials. And the fact that it takes an entire page of explanation should give you a sense that this is a long process. These are hard problems. Okay, so we are going to factor 6x squared minus 11x minus 10. Now we already know what the answer is, so why don't we just go ahead and write the answer up here because we happen to be lucky enough to have it. It was the problem we just did on the last page. So what was the answer? Nate? 3x plus 2, 2x minus 5, that was our answer from, yeah, good. Okay, so this is the answer, so we'll have it at least up there so we can compare. Hopefully at the end of this page we get that answer. Okay, step A, draw a rectangle with 4 smaller rectangles in it. There it is. It gets harder from here. Put the first term into the top left rectangle, so 6x squared goes right up there. Put the last term into the bottom right rectangle, minus 10, got to grab those signs, goes right there. Now a big part of this method is figuring out what goes into the other two blanks, and it isn't minus 11x. It has to do with the minus 11, but we got to do work. The toughest part of the problem is figuring out what goes in those two blanks. So part D says multiply the two terms on the diagonal. So let's go ahead and multiply these two guys together. And what do we get? We got negative 60x squared. So I'm going to write that here where it says product equals negative 60x squared, right? So what does that mean if we multiply the two blanks together? What are we going to get? We better get negative 60x squared, right? When we multiply these two diagonals, we get the same thing both times. So this is an important piece of information we just got, is that the two blanks better multiply to negative 60x squared. It turns out that, okay, so all we're going to do is list all the ways to multiply two things together to get negative 60x squared. And again, to save a little bit of writing, I actually listed them all here. But just take like a random looking one like this guy right here. What do you get when you multiply those two things? Negative 60x squared. So that's all the possibilities for multiplying two numbers and getting negative 60x squared. And there's this little detail here. It says, what? List all the factors. There's something about, oh yeah, here. Each factor has to have a single x in it. So notice that everything has an x next to it, right? So negative 3x, positive 20x. Alex. Alex says the sum of these two is 11x. Is it? So the sum of these guys is negative 11x. And finally, the negative 11x, which was the only thing we hadn't used from the original problem, right? There it is in the middle, negative 11x. That's the thing we're looking for in the sum. And so 4x and minus 15x is the winner. So that's kind of what we have down here in part F. It says circle the factors that add up to the middle term. So the hard part of this problem is done. The rest is going to be pretty straightforward. But let me try to connect this to what we saw last time. Last time we looked for two numbers that had a certain product and a certain sum. We're doing exactly the same thing here. The only difference is that the product isn't just sitting here. This is what we were looking for before. We wanted two numbers whose product was negative 10, right? But it turns out what we really want is two numbers whose product is negative 60x squared. And then the sum is absolutely still the thing in the middle. I want them to have a sum of negative 11x. But the hard part here is that it isn't just looking for a product of negative 10. Turns out it's a product of 6x squared times negative 10. So negative 60x squared. What's that, Fiona? Yes, the reason is because of that stupid 6 in the front. That's what makes this hard, right? All the problems that we had last class were just x squared. But if it's anything other than x squared, like a 2x squared or a 3x squared or a 6x squared, that's when we have to do this process. Jasper? That's the question. Okay. So here's what we do next. Is it says put the circled factors into the empty boxes in either order. Okay, so let's put them into here. So this is now like way later in the problem, but we found 4x and minus 11x, right? Oh, 15, thank you. It doesn't matter where you put it. Yeah, doesn't matter where you put it. Okay, so that comes from way down in the bottom of the problem. So let's actually start on this guy right here. So it's filled in just like we had up above. And so here's the last step of this process. It's part H. It says factor out the GCF, the greatest common factor, from each row and from each column. So let's do that now. Looking at the first row, what number goes into 6 and negative 15? It's 3. That's the biggest number. There's something else that these guys have in common. Is an x. Do you guys agree there's an x in both of them? Is there an x squared in both of them? No, there's only a single x over here on the right-hand side. So you can only pull out like the smallest thing that appears, right? You can only pull out what's there. So I can't take x squared out of both because there aren't enough x's in the second thing. But I can take x out of both. That's that. Looking in the second row, What's the biggest number that goes into 4 and negative 10? Is 2. Are there x's in both? No, so we cannot take anything else out. And then we go to columns. The biggest number is 2 because there's a 6 and a 4. And I heard a bunch of people also say x because indeed there's an x in both. And in fact, every time you do this, there will always be an x in both first column and in both first row. And then minus 15 and minus 10, what goes into both? Yeah, so negative 5 is the right thing. I'm going to say 5 and then we'll take care of the signs. So 5 is in both, right? Is there an x in both? No, okay. So then the last piece of this puzzle, I'll underline it here. It says include a positive sign or a negative sign based on the sign of the very first entry in the row or the column. Whatever the thing is that's first in the row or column, that's the sign that gets copied. No, it doesn't matter where you put the numbers. Nope, doesn't matter which order you put them in. But this was a positive 6x squared, yes? So that positive leads me to a positive here and a positive here. It's whatever's first is the thing that governs. This 4x was a positive, which gives me a positive where? On the 2. This negative 15x means there's a negative where? Right up above. So I'm going to put a negative sign. I'll put it bigger, but that's the one that leads up there. And it's always the same number that is kind of left out of the party. Which number had no impact on the signs? Is that negative 10. Doesn't matter what the sign of that thing is. It's just the sign of the leading term, the thing that's first in the row or column, okay? And then we just have to read off the answer. So here it is, 2x minus 5, 3x plus 2. 2x minus 5 and 3x plus 2. Okay, so that is the hardest kind of factoring that we will see. Pat yourselves on the back. It's a long process, but it gets easier with practice. It's always the same process. So activity starts on the next page. Raise a flag if I can help.